Hi all, how you going? Today we're going to go through a complete question that you might see in the exam. So this is the concept of a electron being accelerated and then put through a parallel plates with an electric field there, and what we're looking to see is if it actually gets through the field and how much it might be deflected. So I'm just going to go through and I'll make these notes available to you, so hopefully that'll be useful. Rather than rewriting this, I thought I'll just talk through it and then I'll shade. Alright, so we can talk about stuff that you actually are needing to know. Right, so the key thing that we are looking for here, highlighted. So, and I'll change that colour. Right, so key thing here, we're using the first concept is Electron Gun. So any question that you're going to get asked will have different steps. So the first step of any question could be to actually work out how fast the velocity of the particle's going. And that's what the electron gun does. It works out the acceleration of the ions, and so obviously their velocity as they enter the next electric field. So you need to use the work done formula. So it's just simply a matter of working out the charge of the electron and then the voltage that you're putting that through, and obviously your units are going to be in joules there. So that will work out what we classify as the work. The work is equal to the kinetic energy that are going, and so therefore the next key step, as we saw in the previous video, is to rearrange your formula, and the examiners like to see you rearrange that before you actually use it. So now I've got my velocity is equal to 2 times the kinetic energy over the mass. Simply just a matter of putting that information into the formula. Now this is actually showing you a proton being accelerated. So a proton is simply got a little bit more mass than an electron, and so you can see what's actually happening over there. So ultimate thing is we can work out the velocity of our particular proton going down through there. Alright, so that's the first step in any question. Now sometimes they'll give you the velocity. If they do, then you don't have to do step A. Right, so what's going to happen is this proton is going to enter the electric field. Alright, there's electric field here, 0 volts, 2000 volts. Our second step is to work out what the electric field strength is inside this particular between the two plates. So we know the potential difference across there. The electric field strength is given by this formula here. Okay, potential difference over the distance. So we need to know how far these plates are apart, and we simply divide the voltage by the distance, and that will give us our electric field strength. Now electric field strength could be newtons per coulomb, newtons per coulomb, or it could be volts per metre. In this particular case, because we're using the voltage and a distance, we are working out electric field strength in that unit. So that's step B, right, is you need to always work out what the electric field strength is. Again, they might tell you what it is, so if they tell you, you don't have to do step B. Alright? Not every question is going to ask you to do everything, but you know they're going to ask you to do parts of. Alright, so the next part of this question would be step C, which is to find the acceleration of the electron or the proton inside the electric field. Alright, so when we start looking at that, we would then need to consider the acceleration. Now acceleration is this formula here. Acceleration is in fact the force divided by the mass, isn't it? Alright, now we know the force is equal to, or electric field is equal to the force divided by the charge. So in other words, the force is equal to the electric field times by its charge divided by n. Now we know all of those values, right? So we can put those in there, and typically you're going to get something like 4.78. It's going to be something like 10 to the 12. You get a bit of a feel once you do a few of these questions what the sort of values that you're looking at. Now that is the acceleration that the proton will experience inside this electric field. Right? So it's in units of meters per second. Alright, so that's the third step. So what's going to happen to this particular proton? Now we would assume this proton, as it comes through the electric field, would be assuming that that proton would probably go in that sort of direction there, wouldn't we? Away from the positive plate. That's what we're predicting. So what we need to know is how long it's going to spend inside the electric field to see how much it's going to get deflected. Now we need to know the length of that particular field. Right? So when we start looking at these values here, that's the length there. I'll just undo that. Right? So that's our length there of the actual field itself. So it's 9 centimeters. Okay, that field is 9 centimeters, and so therefore the velocity we already know. We worked that out in part A. So the length that travels is 9 centimeters. That's the speed it's going at. That will tell us how long it takes to get through the plates. So that point there is really important when we start looking at trying to work out how much it's going to get deflected. So if we know how long it's in the field for, we should know the effect of that acceleration on the particle. Now step E is looking at the deflection of the particle. Now you would recognise this formula here from when we did projectile motion. In this particular case, there's no vertical velocity because it's coming in horizontally. It could be that there is a question where you have a horizontal velocity or vertical velocity initially. If we do, we just treat it like we did when we were looking at gravitational fields. Anyway, what do we know here? We know that the velocity, the acceleration due to the electric field, we know the time it's going to be in there, so we can substitute those two values in there and we can work out its vertical displacement. So it's going to be displaced by 0.2 of a metre, which is 2 centimetres. Assuming that this thing here enters the centre, we know these plates are 4 centimetres, it's going to possibly hit right at the end there, isn't it? So it might actually hit the end of the plate, but it's certainly going to work out. Now the final step that you would be asked for any question might be to calculate its exit velocity. Now we know the horizontal velocity because that was what we worked out in part A with the electron gun. Alright, so what we'll have to do is we'll have to use our final velocity is equal to initial velocity plus the acceleration vertically times the time. We know AB, we know the time, so we can work out what the final vertical velocity is going to be, and that's that value there. I haven't put the units of meters per second in there, so which I should do. And once we want to work out, obviously it's a bit like what we were doing before when we were looking at projectiles hitting the ground. We use the horizontal velocity, we use the vertical velocity, and we use Pythagoras to find its final velocity. And again, we also have to find the angle. So the angle will be using our inverse tan like we did when we were doing that. So the proton exits with a velocity of 1.07 by 10 to the 6th at 24.2 degrees below the horizontal. Okay, so you can give the direction there associated with that question. Alright, so any question that you do could include all of those steps, and most likely just for time factors in an exam or in a test we might ask you some of those steps. So we might give you the values, so obviously you don't need to do every step if you've been given the answers for that. But essentially what I would do is make sure I could do all of those steps, and if I could then I would be able to answer any question to do with the motion of charged particles in electric fields. Just want to quickly show you another question. Obviously if you only had 200 volts, that would give you 200 electron volts worth of kinetic energy. That particle there would be going a lot slower, wouldn't it? Now, I thought I had a question here. Yes, this is the question I want to show you. I saw this one in an exam, and I'd asked my students after the exam, and a lot of them really struggle with this, because every question they'd ever seen in an exam was always to do with a particle coming in horizontally. So what happened in this question here is my electron my electron's actually coming in at an angle of 30 degrees. Alright, so we treat this exactly the same as what we do in any other time. Because I was given the velocity, I didn't need to use my electron gun, but what I did need to do was I did need to break my velocity into vertical components and also horizontal components. Alright, so because you need to know what the horizontal velocity is as it enters, and you also need to know the vertical component of velocity as it enters. The electric field strength is no different, so we work that out using our potential difference over the D. Our acceleration is going to be no different, because that's simply just EQ over M, so that's no problems. Right. Where's the difference in this question compared to what we might have done before? Well, we have initial vertical velocity, so when we put this into the SV formula, right, what happens is that we have to put in our initial vertical velocity there. Right? We've still got our AV, which we calculated before. We've still got our time of flight. Now our time to get through there is going to be slightly different because it's accelerating vertically as well, isn't it? So therefore we can work that out SV, right, which is no different from really what you would have done in the past. So that's an interesting variation of the traditional question. So you just need to be realistic and looking for something slightly different. Again, if that's the first time you've ever seen a question like that in the exam, some students might struggle with that. But if you've got the resilience to look at a question and go, oh, I think it's this, then that should be no problems for anybody. So the secret is make sure you do a number of these questions, certainly out of your workbook, to make sure you feel comfortable with those.